Students, today we're going to be looking at different types of bolt assemblies. So looking at three examples here. Here we have our normal straight assembly. So we have our bolt with a two-sided view of the head. There's the thread. It goes through the hole. There's the washer and the nut. And then next to it we have what we call a set bolt assembly. That's where we have a washer underneath the bolt head and it screws directly into the metal part B and into the hole, the thread that you see here. And that black part there, that's the pilot hole. And then next to it we have what we call a stud assembly, and a stud is basically like a bolt, but instead of having a bolt head on one side, it's got thread on both sides. It screws straight into metal part B, and the other side you also have a washer and nut, and you can of course see the difference in the top views. Now in the top view you can see that the bolt head is just a circle with a hexagon around it, outscribed, and the same here with the set bolt assembly, except you can see the washer going around it, which is bigger than the bolt head. And then next to it here we have the stud assembly. If we zoom into that one, you can see the thread. And typically when you have outside thread, you have the break on the inside circle there. The break can be anywhere as long as you have it. And of course the thread is less dark than the rest of the bolt head and washer. Then, so for today's exercise, we're going to be looking at an M20 bolt. That's a size with a maximum diameter of 20. But here by the 3D model, we can actually see that bolt that we're going to do today. So I've drawn just two parts metal, metal part A and B. Any size, the size of the metal doesn't actually matter there. Okay, the height of each is 15 millimeters. And then if we take it to the front, you can see there clearly with the hatch lines on each part going opposite directions. Here we have the bolt head. Then we have what we hear, the plain portion. This is the part of the bolt that actually has no thread on it. Then we have the thread going through. Then it's covered by the washer here that's actually underneath, and the nut that is screwed on from the bottom up. And then you can see that the bolt actually rests inside a hole that is slightly bigger than the rest of the bolt. Okay, and so the bolt drops into the hole and then it's tightened from the bottom, in this case with a washer and a nut. So if we zoom around a bit, you can actually see. Now typically when we draw a bolt assembly, or any assembly for that matter, any fastener like this one, we do not draw the fasteners cut. So even if we cut the entire object, so this could have been part of a much larger assembly, we do not actually cut the fasteners. So the washer, the bolt and the nut remains uncut. So look at it from the side, you can also see there's the metal. You can see a bit of the thread disappearing behind the washer and the nut. So if we disassemble this basic assembly, you can actually see that the two metal parts, A, it's got its hole, so basically the back of the hole is still left, and that's why you still have corners here and here. And then if we zoom in, we can actually see that the washer is basically just a flat ring, and there's a thread inside the nut as well. You can clearly see it sticking out there. So the thread of the nut goes into the bolt. Right, then focusing on the bolt, we can see that this is a V-type thread. You can see that it basically has a V cut into it. Now there are different ways of doing thread. A special milling machine can be used, or tap screw, okay, or it can be done on a lathe. Whatever method is employed, you do get different types of thread. So you get tapered, you get V, you get square, and so on. But understand the focus of today is not the type of thread. That will be done when helixes are done, so we're not going to be concerned about that now. So we are only going to draw the thread as a double line today. Okay, so going to the drawing page, I'm going to show you exactly how to draw a bolt. Okay, so step one, we're going to start with the center axis that's going to cover over the front and the top view. Okay, so the top view will be here, the front view below it. We're not going to draw the entire top view, basically just the washer and the bolt head. The next, you want to go and put down the face side or the size of the bolt. Okay, now very important, remember that we are working today with an M20 bolt. So if we zoom in, you can see here that the face side of the bolt head or nut has a size of 1.5 times whatever M is. So the maximum diameter of the bolt, which is the M, okay, so is 20. So if we multiply that by 1.5, we get 30. So the radius on your compass will be 15 and you construct that circle. And then you want to draw the hexagon around that circle as a dark line, but also it's outscribed. So you have to basically draw the hexagon around the circle and not inside. So if it was inscribed like you've done before, you would put your compass down and swing it around, but this is different. So all you're going to do here is you're going to take your set squares and you're going to be using the 60-degree angle on the circle. So when you get the set square touching the circle, with others the tangent point that you see there, you simply draw a construction line, do the same on the other side. You shift your set square on the t-square until you get the tangent on the side of the circle and you draw the construction line. And once you've constructed all sides tangents going around, then you're going to draw a dot. With obviously the top and the bottom line, you're going to simply use your t-square and move it up until it touches the circle and draw the line across as well. Right, next we want to go and construct the heights of the bolt head. So to find the height of the bolt head, you have to use this formula. It's usually given in the exam as well, but in case it's not, so you multiply whatever m is. So if it was an M40 or M60 or M10, you would use that size, but for today's exercise we're using 20. So you multiply it by 0.7, and in this case it will give us a height of 14. So you have to use this multiply by 0.7 times 20. So that's a formula that you have to remember. M20 times 0.7, and we get 14 for the height of the bolt head. Right, next what we want to do is we want to go and construct our compass points. So to do that, you go and you take the corners down. Again, this gap you can make anything. I made mine 2 centimeters. So you're going to draw the construction lines down from the top view that you see here, the 4 points. So then you're going to mark down a starting line, and then you're going to measure 14, mark the base of the bolt head, and then you're going to go to these little blocks that you see. You see that the bolt head has been divided into 3 blocks, a big one in the middle and 2 smaller ones on the sides. So you're going to go to the corners and you're going to connect them with construction lines. Just draw construction lines across. You'll see mine is like a Y, and that will automatically give you. So if you go from this corner through to that corner and you lengthen until you reach the center, that will give you the compass point for the arc in the middle, and these 2 smaller ones will give you the arc for on the sides. Next, what you want to do is you want to go, you put your compass down on that center, you move it up until you're at the top, and you swing your compass around, and that will give you the central curve. Then to find the small curve, you put your compass down on the compass points on the left and right side. You simply put it down, you line it up with the curve point that stopped on that corner, you swing it in, and when you reach the top, you stop. Alright, now we're almost done with the bolt head. To finish with the bolt head, you also have to take into account the 2 chamfers that you're going to find. So these little chamfers is to allow the socket or wrench easy access on the bolt head. So that it's not so tricky to get it on there. So you take these 2 chamfer points, you take it down, and then you are going to draw the chamfers at 30 degrees to the face side. So use your set square for that one. So where that point is marked down, you simply put your 30-degree angle of your set square on that point, and you can immediately go and just draw it solid there on that corner. And obviously you just swing your set square around and draw it on the other side as well. Right, once you've done that, you want to go and draw the face side with the solid line. So now you can actually see it for me. See there, you can see that little chamfer there. There you can see that chamfer, and there's the chamfer from the side. And then you can also just connect the rest of the corners to finish off the bolt head, and the bolt head is done. Right, next what you want to do is you want to go and mark down the maximum diameter. Like we said, it's an M20 bolt in this case. So you go from the center, and I mark 10 to each side to get the size of 20 diameters. So I just go from that point across, and you can see those little marks that I made there, and that is the mark on 20. You'll see it's supposed to be just on the right of that corner, and if it's not, then you obviously know that you've made a mistake. Alright, next what you're going to do is you're going to take your maximum diameter down. Now for today's exercise, we're going to make the bolt length 70. Now please keep in mind, when we're talking about bolt length, we are not talking about the length including the head. So we're talking about the distance from the base of the head and the shaft going all the way to the tip. So whether I'm talking about bolt length or shaft, it's the same thing. So the shaft running down is the bolt length. And that wording could be important for the exam as well. Next, you want to go and mark down the minimum diameter. Now, in most cases in the exam, the minimum diameter is not given. Okay, so typically on a bolt packet, if you go to any hardware store, buy a packet of bolts, you'll see that it will read something like M10 minus 8H. So the H always refers to the minimum diameter of the thread. Okay, now if it's not given, all you have to do is you go to your M20 and you say, what is 10% of that? Well, 10% of that would be 2. So all you then do is you mark down 2 on each side to get your minimum diameter. So 20 minus 2 will give you 16 in this case. So the distance from there to there is 16. So obviously measuring from the center, it would be 8 and 8. Next, we want to go and draw in our tip. So that tip must always be at 45 degrees. So where the minimum stops on the point, you just go at 45 degrees and you stop on the side and go across. And again, you can draw that dark straight away. Next, you want to go and mark down your plain portion line. So that's the line that separates the part with a thread and the part with no thread. Now, the plain portion line always, okay, has a length of 2m plus 6 if the bolt length is less than 100. Now, it's very, very unlikely you'll ever get a bolt that is larger than 100, okay, or longer than 100. So, and in most cases in the exam, these bolt lengths will be given to you anyway, but for in case it won't be. So the formula for the thread length, note I'm not saying the bolt length now, I'm saying the thread length, is 2 times m plus 6. That's the formula, okay, if it's not given. So 2 times 20 will be 40 plus 6. So the distance from there to the tip, and I'm talking about to the end here, right down to that line, that is going to be 46. And what's left is the plain portion. Next, you can draw the outline dark as well. And then we have to go and draw in the minimum thread as well. But please take note, the minimum on the bolt has to be in between dark and light. It's not quite as dark as the dark lines, but it's not quite as light as construction. It's kind of in between. So now that your bolt is left, you can actually see what it's going to look like. So there you can see the minimum thread, that distance being 2, or the diameter being 16 across. And when you reach the plain portion line, you have these little triangles that you can see here. Right? This is what we refer to as the run-out thread. That's the part where the thread is cut into the metal, but it starts running out, okay? Because if the tap screw stopped or the milling machine, you stop cutting into the metal. So this is not quite as deep as that, it's becoming more shallow. So this run-out thread is always indicated with a small triangle that's also in between dark and light, and that line has to be at 60 degrees to the length. And there is our bolt is now complete. Right, next we want to go and look at how do we actually construct a bolt when the head is the two-sided view. Remember this hexagon, if we're looking at it from this side or from the back, you can see 3 sides, so that's why we have the 3-sided view here. But you can turn this so that we can actually see 2 sides, okay? So the 3-sided view is more common, but it does sometimes happen. So just to reconstruct what we had before, I'm just going to place all that down. So all you're going to do is you construct this again, okay? So imagine you didn't have a 3-sided view, it was like this. So you take the corners down again until it lines up. So that's it's the same height as you would have from the 3-sided view, obviously. But you can draw the outline solid straight away. Then what you're going to do is you're going to go from these 3 points at the top, and you're going to go at 60 degrees from each point with your 60-degree set square, and where they meet we have our 2 compass points. Obviously we're not going to have 3 curves this time, but only 2. And then you're simply going to put your compass down, line it up with the top, draw the curve, repeat on the right side, and draw the corner in the middle, and your 2-sided view is done. So the 2-sided view is actually a little bit easier than the 3-sided view, and that's also why it normally counts less than that one. Right, now to finish off the exercise, we're actually going to be adding the washer and the nuts on the bottom side. And we're also going to be adding the part metal A and the part metal B, okay, that we are actually joining. So it's a basic assembly. So to do that, I have redrawn the bolts for now as yellow construction lines, just to make it much lighter. Please take into account that the dark blue are dark lines. Okay. So to start, we're going to add the washer in the top view. So there you can see that the washer is going round the bolt head in the top view. Okay. And this washer always has a diameter 2 times m. So if m is 20, the washer has a diameter of 40. If m is 15, then the washer has a diameter of 30, and so on. But since we're working with m20, it's going to be have a radius of 20 or diameter of 40, and again use the same center for as the bolt head. Next, we're going to mark down our 2 sheets of metal. So if I zoom in here, we're going to make each height 15 millimeters. So the height from the base of the bolt head is 15, and the second metal part is also 15. And please take note that the line is going to stop when it hits the bolt. So you can see here that the line doesn't go over the bolt, it actually goes around the back, and that's why the bolt is covering the corner or edge where the 2 metal parts meet. Now the reason why the bottom line is solid, because this line will actually be used for the washer, because remember the washer is going to keep its outline, okay, and there you can see it. So the washer is going to cover that area of the thread, and that's why that line there is going to be solid. Now again, to draw the washer, now remember that the washer has a size of 40, okay. So the rule is you can simply take it from your top view, that 40, and bring it down, project it down, and you can mark it there. Or you can go from your center and simply measure 20 to each side. Then how thick or high must the washer be? That's always 10% of the diameter. Okay, or if you will, M20 times 0,2. Okay, so if the washer has a diameter of 50, then that will be 5. If the washer has a diameter of 80, then that will be 8. If the washer has a diameter of 20, then that will be 2. So in this case, that is a diameter of 40, so we made it 4. Okay, so the wash is fairly easy to remember. Next, we want to go and draw in our nut. Now you can see that the nut is exactly the same design as the bolt head. So we're going to stick with 3-sided again. Okay, you can see it's drawn exactly the same. So the same method you apply to draw the bolt head, you're going to apply to do the nut, with one difference, is that the bolt head, okay, has a height of 0,7 times m. Right, so you take your calculator and you multiply 0,7 times 20, while for the nuts, from that distance from the base of the nut to the end of the nut, that height there is 0,8 times m. So it's slightly higher than the bolt head, okay, and that's going to work out to 16. So the bolt head is 14 and the nut is 16. Okay, now normally at this, when you get this far, you would actually go and draw your shaft solid. Okay, so you can see there's the shaft, there's the plain portion line, there's the tip, there's the outside, and after that you would add your minimum thread as well and the run out. So there you can see the run out going up, it disappears behind the nut, disappears behind the washer, and it comes out the other end until the plain portion line, and then at 60 degrees. Same on this side. And then on the metal, I don't have a specific length for it, so I've just add continuations here to indicate that the metal is actually carrying on. Then, of course, we want to add some hatching on the metal. So even though the entire view has been cut, we technically only add hatching to the metal part A and B in opposite directions, because there are 2 different sheets of metal. So this one goes to the right and that one goes to the left, both at 45 degrees. Take note, this is the same part, therefore it gets hatched the same way, even though it's in different areas. Alright, so just to recap, so starting from the top, the face side of the bolt head and nut, okay, has a size of 1.5 times m, and in this case it gave us 30. Then the washer that goes around it is 2 times m, so that gave us a diameter of 40 or radius 20. The bolt head has a height of 0,7 times m, okay. Each sheet of metal A and B has a height of 15 on this exercise. The runout thread is at 60 degrees, while the tip is at 45 degrees. And it has to be those angles. Then the washer as, like I said, as a diameter taken from the top view, and the thickness is 10% of that, or if you will, m20 times 0,2. Okay, so that's the formula. The 0,2 is always that. Okay, then the nut has a height of m times 0,8. Okay, in this case it gives us 16, and then the maximum thread is 20, and the minimum thread is 10% less each side, and then the distance from the tip to the plane portion. With other words, the thread is 2m plus 6. So in this case, 2 times 20 plus 6 gives us 46. Please take a caption of this. You will definitely need these formulas at a later stage as well.